squared equals g m1 over r. And then we square both sides, and we get v equals the square root of g times m1 over r. So like I said, g is the gravitational constant, m1 is the mass of the Earth, the larger body in which the satellite is orbiting, and r is going to be the distance between the two objects, the distance between the centers of the two objects. So this is the equation for orbital velocity. Now, just the orbital equation in general, if you know the basics, Fc equals Fg, you basically have it covered. It's just a little bit of algebra and then you got it. So let me move this a little bit down. So going back to our original, m2v squared over r equals g m1 m2 over r squared. And then this v squared equals g m1 over r. Well, how do we get v in terms of like pi and r? Well, v is basically the distance traveled over time. So it's actually 2 pi r, which is the circumference over time, over the period, sorry. So the period is basically how long does it take to do one full rotation. And so we're going to basically square this. So we have 4 pi squared r squared over t squared equals g m1 r. And so we can just move some stuff around. And so when you move this over here and this over here, we just get, oops, can't see anything. You get 4 pi squared r to the third equals g m1 t squared. So I would say this is the basic orbital equation that you need to know. And so how do we derive Kepler's law? Well, essentially, to derive Kepler's law, we're going to need to find what is the constant. So if we go up here, we're going to let me just move this over a little bit. We're going to try to get t squared by itself. So we get t squared equals 4 pi squared over gm r to the third. And basically, this is the universal gravitational constant, which never changes, pi never changes, and the mass of the planet never changes. So all this is a constant, which means we're just left with t squared and r to the third. And we say these are proportional. This is the sign as to show that these two terms are proportional. So this just means that the period of the object squared is proportional to the distance between them cubed. So this is also Kepler's third law. So that's all for this video. Thank you for watching. If you want more physics kind of help, I'll try to make some more. I really just use them to study for tests. So I hope you have a good day and bye.